Today we are finding unique numbers, missing words, scoring words, validating braces, finding narcissistic numbers, and then we are helping Pete bake cakes. Hello world, and this is versus Codewars. We begin today with the warm-up segment, a series of easier katas in order to prepare for the more difficult katas later in the episode, starting with the importance of staying hydrated. Our cyclist here likes to drink half a liter of water for each hour of cycling. Given the time in hours, the goal of this kata is to return the number of liters our cyclist will drink floored to the smallest value. Let's go ahead and give this a try here. Constant liters. Our time in hours, and what we'll do here is we need to return the amount of liters our cyclist will drink rounded down to the previous value. We do that with math.floor. We take our time, which is in hours, and we multiply it by 0.5. Another way of saying divided by 2. Let's go ahead and punch this into Codewars and see what that looks like. And we are good on that. Our next warm-up kata, we are checking to see if a number is divisible by two numbers, x and y. Let's give this one a try here. Const is divisible. We take our number, our first and our second divisors, and we return true if number modulo first, that is the remainder of number divided by first, is equal to 0, and the remainder of number divided by second is equal to 0. This kata ensures that all inputs will be positive non-zero digits, so we don't need to check for divide by 0 here. So let's punch this in. And we are good on that. Our next warm-up kata, we are given a character and two numbers, and based on the character passed in, we have to perform a certain mathematical operation on the two numbers passed in, plus, minus, times, or divided by. Let's go ahead and give this a shot here. Constant basic up. We have our operation character, our first value, and our second value. Second. And what we'll do here, we'll use a switch statement on our up. We'll check to see, and we'll return the result of a certain mathematical operation depending on what this is. Case plus, we return first plus second. Case minus, we return first minus second. Case times, we return first times second. And case divided by, we return first divided by second. Now, since we're dealing with a division here, now, it doesn't say anything here about whether these will be non-zero. So what we're going to go ahead and do here, if we are given a divided by here, if second is equal to 0, we will return number.nan, not a number. Let's go ahead and punch this into Codewars here. Identifier basic up has already been declared. Whoops. Let's try that again. Could have sworn I did Control A first. Anyway, we are good on that. Our next warm-up kata, the goal of this one is to write a function that returns both the minimum and maximum number of a given array. Let's go ahead and give this a try here. Let me read out the story here first. Ben has a very simple idea to make some profit. He buys something and then he sells it again. Of course, this would not give him any profit at all if he was simply to buy and sell at the same price. Instead, he's going to buy it for the lowest possible price and sell at the highest. Good idea. Buy low, sell high. Anyway, here is our function signature here, const min max. Again, we are returning the minimum and maximum value of the integers of our array. And we do that, we are gonna use a little destructuring assignment here. So in these brackets, we're gonna do this, math.min. We're gonna spread out the integers in our array as arguments to this function, and this will return the minimum value of those arguments. Similarly, we'll do math.max ... arr. Likewise, this will spread the integers out as arguments in this function and get the maximum value. Let's punch this into Codewars and see what that looks like. And we are good on that. Our next warm-up kata, we have a class for a fighter, which has 4 properties: a name, some health, damage per attack, and to string. Our goal here is to create a function that returns the name of the winner in a fight between these 2 fighters. Each fighter takes turns attacking the other, and whoever kills the other first is victorious. Death here is defined as having health less than or equal to 0. Alright, let's go ahead and give this a shot here. Alright, I imagine we are already given this class here already. So I'm gonna go ahead and copy this into our local solution here. And then our function signature is constant declare winner. It takes 3 arguments. Our first fighter, our second fighter. Let me just go ahead and player 1, fighter 1, fighter 2, and the third argument that determines who goes first. Alright, what we'll go ahead and do here is, now I imagine, let me have a look at these test cases here. So it looks like the third argument will be the name of the fighter that goes first. So what I think we'll go ahead and do is let active fighter equals null if fighter 1.name equals goes first, then we'll set active fighter to fighter 1. Else if fighter 2.name is equal to goes first, we'll do active fighter equal to fighter 2. And then in a while true loop, what we're going to go ahead and do is I think we'll go ahead and keep track of our other fighter 2. Other fighter, fighter 2, and other fighter equals fighter 1. So what we're doing here, based on who goes first here, we're keeping track of an active fighter and an other fighter. And if fighter 1's name is equal to the name of the fighter that goes first, we set active fighter to fighter 1 and the other fighter to fighter 2, his opponent. Likewise, if fighter 2.name is equal to the name of the fighter that goes first, we set the active fighter to fighter 2 and then the other fighter to fighter 1. So what we'll go ahead and do in this while loop here, I think we're going to go ahead and other fighter dot health minus equals active fighter dot damage per attack. So we have our active fighter inflict damage to the other fighter, taking away from their health a number equal to the active fighter's damage per attack. And then if other fighter dot health is less than or equal to 0, that means the other fighter is gone, dead, and died. So we'll go ahead and return the name of the winner. Return active fighter dot name. Otherwise, we'll go ahead and swap the roles and set the other fighter to the currently active fighter for the next turn. And we do that by doing this. Const temp equals active fighter. Active fighter equals... Oh, I have another idea to go about this. We used a destructuring assignment during one of our earlier warm-up katas here. We can actually do this. Active fighter, other fighter. We use a destructuring assignment here. And we use a destructuring assignment here to swap the values of these two fighters here. And this ought to work. Let's go ahead and feed this in a node and see what that looks like first, however. Let's pull from this test right here. Copy, paste. Console.log. Alright. Anyway, we have our fighters here named Lou with 10 HP and 2 attack. And a fighter named Larry with 5 HP and 4 attack. And in this fight, Lou is the one who goes first. So let's feed this in a node and see what that looks like. Node warmup fighters.js. And we do in fact have Lou here. Let's go ahead and punch this into Codewars and see what this looks like. First, let's try without the fighter declaration here, just in case that's already provided. And we are good on that. Finally, we are taking an integer n and a digit d. The goal here is to square all numbers k greater than or equal to 0 and less than or equal to n, between 0 and n. And our goal here is to count the number of digits d used in the writing of all of those squares. Let's go ahead and give this a shot here. Const nb dig takes an n and a d. Alright, first we're going to go ahead and find all of the squares between 0 and n. We're going to keep track of them inside this array here. For let I equals 0, I is greater than, less than, or equal to n plus plus I. Squares dot push I to the power of 2. This is the exponent arithmetic operator. It takes this I here and raises it to the second power in this instance right here. Alright, let's go ahead and console.log that and see what that looks like here. Squares. And what we'll do down here, console.log nb dig 25 and 1. Node warmup count digit. And we have all of the squares here between... we have the squares of all the numbers between 0 and n, which in this case is 25. Alright, what we need to do from here is to filter out any digits in this array that does not include the digit that we have passed in here. So what we'll go ahead and do is return squares.filter. We take a square in this predicate function here. We take that square, convert it into a string, split it into its individual characters, and check to see if it includes our digit. And then we take the resulting array here and we get its length. So let's punch that in a node and see what that looks like. We get 10. That's not what we want to see here, actually. Alright, what's going wrong here? Alright, let's go ahead and first return that array. We have 1, 16, 81, 100, 121, 144, 169, 196, 169, 196, 361, and 441. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, wait a minute. So there are a lot. Oh, okay. We are looking for the number of occurrences of the digit 1. Okay. I was approaching that all wrong here. So what we need to do... we need to join that resulting array together as a string. Split that into its individual characters. Yeah, this is getting a little bit convoluted here. Alright, so actually what I think we're going to go ahead and do is, just to make that a little more readable, we're going to go ahead and take these squares. We're going to take these squares. Join them together with a blank string. And what we're going to go ahead and do is return digit to string. Split that into its individual characters, its individual digits. Filter out any digit that's not the one that we passed in our second parameter. And then get its length. Let's try that. And we do get 11. Let's punch this into Codewars and see what that looks like. Whoops. Hit copy. Hit paste. Hit attempt. And we are good on that. That concludes today's warm-up segment. I will see you in the next kata. Given an array with at least 3 numbers, all of which are equal but 1, the goal of this kata is to return the unique number in the array. This test contains some very large arrays, so performance is going to need to be taken into account. Let's go ahead and give this a try here. First, we need to figure out which of these numbers is the majority number in the array. So what we're going to go ahead and do is we're going to do ahead and let majority number equals null for const elements of array. And what we're going to go ahead and do is if array dot index of elements is not equal to array dot last actually, let's try this actually. For const element of array, if array dot index of element is equal to array dot last index of element, return element. Alright, let's go ahead and run this through some tests here. Console.log find unique 111211. Let's speed this in a node and see what that looks like here. Node unique number, and we get our 2 here. Let's try some tests here. I want to see some here. Console.log math.for math.random. Where's 0 and 1? Just a hunch. Alright, let's go ahead and punch this into Codewars and see what that looks like here. Run the tests. Let's try attempting this. And we are good. One other way I could have implemented this Kata solution without using the for loop was to use the array object's find method. The find method takes one lone parameter, which is a predicate function which is run upon the elements of the array until it finds one such element of the array for which that predicate function returns true, upon which that element is returned. The predicate function takes at least one parameter. The first parameter is the element of the array currently being worked on. The first optional parameter, the second one, is the index of the element of the array being worked on. The third parameter, which is the second optional one, is the array itself being worked on. What I could have done here was use the find method and have the predicate function check to see if array.index of the element passed in is exactly equal to array.last index of the element passed in. Consider having a look at array.findIndex as well, which does the same thing as array.find, only it returns the index of the element for which the predicate function returns true. Back in an earlier episode of Versus Codewars, I did a kata that checked to see if a string contained a valid sequence of parentheses. Here we are doing it again, but with more than just parentheses. Given a string containing various braces, parentheses, brackets, and curly braces, the goal of this kata is to check to see if all of the braces in the string are matched with their correct brace. Let's go ahead and give this one a try here. First, like we did with the last time, we want to go ahead and use a regular expression to match all of the braces in the string. So what we'll go ahead and do, const brace regex. We're going to use a regular expression here, and we're going to look for any instance of the opening and closing parenthesis, the opening and closing bracket, and the opening and closing curly brace. And what we're going to go ahead and do here is, for now, we're just going to go ahead and return str.match brace regex. Let's go ahead and console.log a test case here. Valid braces. We're going to do a opening, closing parenthesis, opening, closing curly brace, and opening and closing bracket here. Alright, let's go ahead and run that through Node and see what that looks like here. Node valid braces. And we have a resulting array that contains each of our brace matches here. So what we're going to go ahead and do is we're going to put that in our matches here. Brace matches equals str.match brace regex. And we're going to keep a score here of our current brace branch, as I like to call it. Parent branch. Yeah, I think a better way to say it is parent score, bracket score, and brace score. And we're gonna, and using a destructuring assignment, we're gonna set these each to 0, 0, 0, respectively. And what we're gonna go ahead and do here is we're gonna iterate over our brace matches here for const brace match of brace matches. And we're gonna run each of these through a switch statement here. Switch brace match. And what we're going to go ahead and do is case opening parenthesis. We're going to go ahead and increment our parenthesis score, parent score plus plus, and break. Case opening bracket. Likewise, bracket score plus plus break. Case opening curly brace it, brace score plus plus break. Now, for our closing ones here, we're going to do case closing, and we're going to copy this down here. And what we're going to go ahead and do is parent score minus minus. But as with the valid parentheses kata we did earlier, we need to check to see if our parent score is less than 0 as a result of that, in which case we return false. And we do that likewise with our bracket score. Let me just go ahead and our brace score. And if we reach the end of this loop without returning false, we go ahead and return true. Let's go ahead and run this through Node and see what that looks like. Assignment to constant variable. Okay, this has to be let. This returns false, which is not supposed to happen. Alright, what's going on here? Alright, let's go ahead and console.log our brace match here. Alright, let's go ahead and console.log at the end of this switch statement here. Console.log parent score bracket score brace score. Oh, okay, I forgot. One crucial thing at the end of our cases here. We actually forgot to break out at the end of each of these cases here. Let's try that again. And looks like it is working now. Let's go ahead and punch this into Codewars and see what that looks like here. Copy, paste, run the tests. And we have a problem. What's going on? Expected true to equal false. Okay, what we'll go ahead and do is return parent score is equal to 0 and brace bracket score is equal to 0 and brace score is equal to 0. Okay. Yeah, I know we're going wrong here. Let's go ahead and try that again. Still problems. What now? Oh, wait a minute. Okay, we actually need to redo this. Okay, we actually need to start this over. Alright. Okay, so now we're back here with our brace matches here. Alright, we again have our parent score, brace, bracket score, and brace score. Each set to 0 here. But we also need to keep track of our active brace. So what we'll go ahead and do is for const brace match of brace matches, what we'll go ahead and do is switch brace match case opening parenthesis case bracket and case opening curly brace. What we'll go ahead and try doing is set. Oh, wait a minute. Okay. I have another idea. Let's brace depth. Set that to an empty array. We'll push this currently active brace into our brace depth here. Then in the case of any one of our closing braces here, of course, as with a case of okay, what we need to do actually is brace score plus plus bracket score plus plus and parent score plus plus, and we'll do just the same with our bracket depth here, brace depth, excuse me. Now, with our closing parenthesis here, we first need to check to see if this closing parenthesis matches. We need to check to see if the last brace in our brace step is the opening parenthesis here. So if brace depth dot pop, this pops the last element out of the end of the array and returns it, is not equal to the opening parenthesis here, we have to return false. And then we go ahead and do parent score minus minus, and if parent score is less than 0, we return false likewise. And then we break out of the switch here. We repeat that with our other two cases, excuse me. With the bracket, and then the curly brace. Alright, let's go ahead and give this a try here, shall we? I imagine we can probably just return true after all that. Assignment a constant variable. This, again, needs to be a let. Yeah, this returns true. Let's try that errant case here in our tests. This returns false. Let's punch this into Codewars and see what that looks like. Alright, run the tests. And again, another problem. Expected true to equal false. Okay, let's go ahead and console.log our brace matches here. Let's go ahead and do that in the Kata solution here. Console.log brace matches. Let's run that again. Okay, we do need to check our brace scores here. Parent score is 0, return bracket score is equal to 0, and brace score is equal to 0. Okay, let's try that now. And what's the problem now? I thought I told you to cut. No. Yeah, let's try that again here. Get rid of this. Alright, let's try that now. Alright, we are good. Here is the better code solution of the day. Pay mind to the code snippet you see below me here. Here, we use an object, mapping each opening brace to its respective closing brace. We iterate through each character of the string, which in this particular case is assumed to consist only of braces. We check to see if the current character is an opening brace. We then push, if it is, we then push that brace into a stack, much like what we did with the brace depth array in our Kata solution here. Otherwise, we check to see if that character is the matching closing brace to the last brace in that stack. If it's not, we return false. At the end of the loop here, we check to see if there are any more braces in that stack. If there isn't, we return true. If there is, we return false. Now, what we did in our Kata solution here, we assumed that the string passed in would contain characters that were not braces, like letters, numbers, what have you. So, we instead used a regular expression here to match all of the opening and closing braces and put them in its own array. But we could have implemented this solution from using that joined into a string with a blank space. A narcissistic number is a positive non-zero number which is the sum of its own digits, each raised to the power of the number of digits in a given base. Given a positive non-zero integer, the goal of this kata is to check to see if that number passed in is a narcissistic number. Let's go ahead and give that a try here. First, we need to go ahead and find out how many digits are in that number. So what we'll go ahead and do is, we also need the digits themselves too. Const digits equals number, not toString. We convert that into a string, split that into its individual characters, map each character, and parse them out as an int. And what we'll go ahead and do is, from here, we'll go ahead and reduce reduce accumulator digit ac plus equals. Okay, what we'll go ahead and do ac plus digit yeah, digits raised. So what we're going ahead and doing here is we're taking our number passed in, we're converting it into a string, splitting that string into its individual characters, mapping each one out, converting them into an integer, and then we're running this through the reduce method here. We have an accumulator here, which is initially set to 0. We have the current digit being worked on here. This third parameter, which would be the index of the element being worked on, but this parameter is not being used, so a generally good programming practice in JavaScript would be, if you don't intend to use a parameter in a predicate function, you just use an underscore here. And then we have this fourth parameter, which is the array itself being worked on here. We take this accumulator here, and for each element, each digit, we add that digit raised to the power of the length of the array being worked on. And then at the end here, we check to see if the result of this operation here, the digits raised, is equal to our number. Let's go ahead and test this out here. Console.log, narcissistic, we pass in 153, for instance here. Let's run this through Node and see what that looks like here. And it returns true because the digits of 153 raised to the power of the number of digits in that number is in fact equal to 153. Let's try 1652. This returns false because the digits in 1652 raised to the power of 4, which is the number of digits in 1652, is not equal to 1652. Alright, let's go ahead and punch this into Codewars and see what that looks like. Alright, run the tests. And we are good. Not really much to say about this one. However, I could have done the exponent arithmetic operation in the map method's predicate function using that predicate function's third argument, which again is the array itself being worked on. I could have taken the return of parseInt on the character being worked on and raised that to the power of the array's length. And then in the reduce method's predicate function, I could have done a standard ACK plus val to add together the values of the resulting array. Given an array of at least 2 consecutive letters with exactly 1 letter missing, the goal of this kata is to seek out the missing letter. Let's go ahead and give this a try here. And what I think we'll go ahead and do is... for const letter of letters, we're going to go ahead and iterate through our letters array here, and what we'll go ahead and do is if letters dot includes, what we'll go ahead and do is from string.fromCharCode letter.charCode at +1 is equal to false. Then we go ahead and return. And we're actually going to go ahead and set that in a variable here. Const next to letter equals... Actually, what we'll go ahead and do, just to add a little context to this, we're going to go ahead and take this constant here, next letter, and we're going to set that equal to string.fromCharCode. This function retrieves the character with the given character code here. And what we're going to go ahead and do, we're going to take letter.charCode at 0 and add 1. So what this does here, this seeks out the character code of the first character of our letter string here, which should be the only character in that string, hence the 0. We add 1 to that resulting character code. Then we take that result and run that through the string object's fromCharCode method, which retrieves the character at the given character code. We'll take that and store that in our next letter here. So what we'll go ahead and do, we're going to check to see if letter.includes next letter equals false. If this letter is not included in our array here, then we'll go ahead and return next letter, because that is the missing letter in our array. Let's go ahead and test this out here. It's important to note that the kata instructions say there will always be exactly 1 letter missing from each of our arrays in our tests here. So console.log find missing letter. We'll pass in this array here. Let's run that through Node and see what that looks like here. Missing letter. And it returns the letter E because that is the missing letter in this array here. Let's go ahead and try another test case here. Some capital letters here. Oops. Let's run that through Node. I expect to see the capital P, and we do in fact see a capital P. Let's go ahead and run this through Codewars and see what that looks like. Let's get rid of this console.log. Hit test. And we are good. Here's a little quip with this Kata solution here. Had I passed in an array of consecutive letters that did not omit a letter, this function would have returned the next letter after the last letter of this array. A more proper solution to avoid this would be to use a traditional for loop rather than a for of loop, and then check to see if we were working with the last element of that array, in addition to if the next letter was not included in that array. If we made it to the end of that for loop without finding the missing letter, we would have returned null instead, to indicate that there was no letter missing in that sequence of letters that we passed into this Kata solution. Given a string of words, the goal of this Kata is to seek out the highest scoring word based on the positions of each of its characters in the alphabet. A is 1, B is 2, C is 3, and so on. The Kata instructions say that all letters will be lowercase and all inputs will be valid. However, I'm going to add a little bit of a stipulation of my own to this Kata. As you can see, I have a full-blown sentence here complete with uppercase letters and punctuation. And we're going to go ahead and seek out the highest scoring word in that sentence. So, let's go ahead and get started here. First, we'll need a regular expression to match all of the letters and all of the words in our sentence. So what we'll go ahead and do, const word regex equals, we're going to seek out all letters here. And what we'll go ahead and do is, I think it's lowercase w actually, console.log sentence.match word regex. Alright, let's run this through Node and see what that looks like here. Node word score. And as you can see, we have all of our words matching up right here. Alright, what we'll go ahead and do, we'll take const word matches, and what we'll do is sentence, convert all of our words to lowercase here, and then match all of our words. Let's console.log that and see what that looks like. And as you can see, we have all of our words in lowercase now. Alright, what we'll go ahead and do is, let's take our word scores, and what we'll do is word matches dot map, pass in a word into our predicate function here, and we're going to take that word, split it into its individual characters, and then run that through reduce. Pass in our accumulator and our character as the predicate into the predicate function here, and we'll set an initial accumulator here to 0. Alright, before we continue, we need the position of the letter A in the alphabet. What we'll go ahead and do is, we need the character code, that is, for the letter A char code, code at. And what we'll go ahead and do here is return accumulator plus char.char code at. And I think it's minus a char code. let's encase this in parentheses here. Alright, let's console.log our word scores here and see what they look like. Console.log word scores. See if that matches up here. Alright, I want to console.log each of the character scores here as well, just to see if I have that right. Console.log that. Subtract 1 here. I think we are good to go here. Let's go. All right, let's go ahead and now word matches and word scores should contain the same exact number of elements here. So let's go ahead and find the index of the maximum value in our word scores array. Const max index equals I think it's word scores dot index of math dot max, and we spread out our word scores in to max's parameters here. Let's console.log that and see what that looks like. Max index. And you see it turns 11 here. 1, 2, 3, 4, 5, 6, 7. No, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright, what we can go ahead and do from here, word matches, we'll pass in our max index, and I expect to see volcano here. Word matches is not a function, because we're looking up an array, not calling a function here. We need to use brackets. And we see the word volcano. Alright, what we can go ahead and do here, we can just go ahead and return that word matches at max index. And we see volcano here. Now, it's important to note that the Kata instructions expects all letters to be lowercase. It's assumed that the return value will be lowercase as well. That is handled up here. Let's go ahead and punch this into Codewars and see what this looks like. Alright, let's hit the tests. And we are good. Now, this kata was only intended to feature strings using lowercase words. However, I decided to spice things up a little bit here and use full-blown sentences using uppercase letters and punctuation as well. If you're following along with me and want to try some of these katas that I do on Versus Codewars out for yourself, try spicing them up a little bit. Add your own little stipulations to it to make these katas a little more challenging, and that'll help you really sharpen your programming skills as well. Use your imagination. Meet Pete. Pete's a baker. Pete likes to bake cakes, and he has a recipe in mind and some ingredients. Unfortunately, he's not too good at math, and he would like our help finding out how many of these cakes he can bake with the ingredients he has available. Given two objects, one representing the ingredients of the cake, and the other representing the amount of ingredients available, the goal of this kata is to calculate the number of cakes our baker can bake using the available ingredients. Before we begin, I would like you to pay attention to this call here in our console.log. We have our two objects here. The first representing our cake's ingredients. It calls, for example here, this cake calls for 500 units of flour, 200 units of sugar, and 1 egg. Alright, in this case, our baker has 1,200 units of flour available, 1,200 units of sugar available, 5 eggs, and 200 units of milk. Note that the milk is not used in this recipe. Our goal here is to find out how many of these cakes can be made with the amount of ingredients here. Alright, let's go ahead and get started here, shall we? What I think we'll go ahead and do is... how about we iterate over the amount of... how about we iterate over the keys of the ingredients this recipe calls for? And let's go ahead and keep score here. That's ingredient scores equals. Place this in an empty array here. And then we'll go ahead and iterate over each key in our recipe using a for-in loop. Let's go ahead and console.log that and see what that looks like here. Console.log ingredient. Let's feed this through node and see what that looks like here. Excuse me. Node baker. And as you can see, it outputs each key of our recipes object here, which represents each of our ingredients. Alright, what we'll go ahead and try doing here is we'll try a little bit of division here. Alright. Let's we'll go ahead and keep track of a score here. And what we'll do is take the value of either available ingredient, if that's not present in the available object, we'll just pass in 0 for that, divided by recipe ingredient. And what we'll go ahead and do is, if the resulting score is less than 0, we'll have to return 0 here, because we cannot make any cakes with the ingredients that we have here, because we don't have enough of that ingredient. Otherwise, what we'll go ahead and do, we'll take our ingredient scores and push in the floor of our ingredient score here. Let's go ahead and console.log that down here and see what that looks like here. As you can see, we have 2, 6, and 5. What we can go ahead and try doing from here is we want to return the minimum of that. Return math.min, spread out our ingredient scores, and we want to return the minimum value of that. That's how many cakes we can make with the ingredients we have available. Alright, let's try another example here. How about this call to cakes here? Console.log. Oops. Here we have a cake that calls for 3 apples, 300 units of flour, 150 units of sugar, 100 units of milk, and 100 units of oil. However, we only have 500 units of sugar available, 2,000 units of flour available, 2,000 units of milk available, but no oil or sugar. Let's go ahead and try that. And it does return 0 here because we can't make any cakes with the ingredients we have available because we simply do not have enough. Let's go ahead and try this one in Codewars and see what that looks like. And let's run these sample tests here. And let's attempt, and we are good. I want you to pay attention to the OR operation in the assignment of our ingredient score in our for loop. Boolean operations like AND and OR can be used in variable assignments as follows. In the case of our OR operator here, this checks to see if the value to the left of the OR operator is a truthy value, like a number or a non-empty string. If it's a falsy value, like 0, null, undefined, a blank string, what have you, this operation will assign the value on the right side of the OR operator to that variable. What we're doing here in our Kata solution here, we're checking to see if an ingredient, the current ingredient in our for in loop iteration, is available in the available object pass in. If that returns undefined, this OR operation kicks in and assigns it to 0 instead, or rather in our case 0 divided by however much of the ingredient that is required by our recipe. And that is going to do it for today's episode of Versus Codewars. If you like this video or you learned something new, drop a like and subscribe to this channel to see me take on more coding challenges on Codewars. As always, if you think there's anything I can do to improve on my code for the better, feel free to drop a suggestion in the comments section below. I hope you have a wonderful day, and I will see you on the next episode of Versus Codewars.